Yeah. That's sorry.
Thank you. Is it working? Is that yours? Oh, it's not on it. There we go. Oh, how come it's down there, man? I want to get it back down there. That was stupid. I don't know what I do, man. I don't know what I'm doing. It's just like it's a funny thing.
You just failed to open PDF.
What?
You just failed to open PDF. The program asks you like to log in when you try to open PDF. Oh no, never mind. Yeah.
Yeah.
Oh yeah. Oh. Huh. All right.
Okay. 216. Two 17, 216, 215, 220. Anyone got a joke for the day? Anybody? Doesn't have to be clean. Maybe it should be. But no one has a joke? Nobody? Huh. I read that students were getting really naughty this weekend at partying. That's what the dispatch said. Is that true? Were you guys all out partying? I had quotes from like a couple of retired OSU professors who were complaining about you students. Were any of you involved in that? Very disappointed if you were. Terrible. You're not gonna admit it? Okay. It's all right. Partying. I had a third beer. I can no longer consume a 24 pack on a Friday night, so. But third one was great. It was 6:30, so I went to bed. It was fantastic. I'm just talking because we've got another minute. I mean, seriously. If you guys aren't going to talk, it's really hard with these face masks, isn't it? I've got it through with them personally.
They have clear masks now.
Clear masks, really?
Yeah, I was thinking about getting them. I don't know how it can still be clear, like you don't have to read through plastic. There are several websites that like literally just like it's a clear mask.
Nice. They just wait around long enough. Good things will happen, I guess. Very bad things. I don't know. Clear masks might not be good either. I don't know. It's hard to say. Does anybody know what's good or right now anymore?
No,
Do we know what's up or down? Anybody?
did we ever know? Will we ever?
I feel like back in the 50s, we might have known what was right, what was wrong. I don't know. It just seemed like that was a certain time. Everybody was certain about something back then. You guys remember that, those days?
The 50s?
Yeah. No?
I did look at those videos that they would show in school that was like, Sally hangs out with too many boys, and she's not a good whatever. Like they would really
Oh,
just
yeah.
try to push the social norms. It's very fascinating.
Well, we still try to push social norms today, don't we?
Yeah.
Especially on college campuses. I mean, my God, that's one big social norm pushing machine, isn't it? College, university, isn't it?
I guess it was just interesting to see that like they did it so blatantly and so
I
obviously.
mean, like on TV.
You like just like apparently like, even in
But you guys don't even watch TV anymore, do you?
like
Does anybody watch TV? Like actual TV rather than just a YouTube on your smartphone, smart thing?
No, but we get like TV, like they'll have like the news channels on like Snapchat and stuff and YouTube, so you can kind of like watch them
Watch it. Okay.
live. I guess some people do still watch TV. Yeah.
I watched TV. I watched TV last night. You know what I watched? Every Which Way But Loose. You haven't seen that movie? Every Which Way But Loose. Clint Eastwood. I mean, it's a great movie. I remember seeing it when I was a kid.
Is that the one with the monkey in it?
Yeah, well, it's not a monkey actually, but yeah.
Well, what, it's a
Yeah.
some type of monkey.
I think it's an orangutan. Yeah. Yeah, but that's the one. Exactly. Yeah, that's a great movie. I mean, I'll probably get in trouble for telling that, but it was on TV, so it's not that bad. Okay, you ready? 220. Okay, good. That time. Okay, so that was the introduction. Is that good? You guys like it? Little introduction to whatever this is. The energy. Okay. All right, we got a lot to do. So, as I was saying, I was a little too gabby last week, so I apologize. We're getting back into the mode of trying to do a, time in class here and make it through a class where we accomplish a lot without going off on a tangent. So I'm going to try to do a better job getting through stuff. I think this is the last slide we were on, but I wanted to come back to it whether we had skipped over it or not. Just to point out that the key point on this slide, if you go back and look at this and see it later, is really what it's that, with trade of stuff, I mean, I think we're indoctrinated to believe that, we basically consume so many things from somewhere else. But the reality is actually most of what we consume is really pretty locally produced. In fact, actually, it just makes sense, right? Despite the fact that you might hear that you're getting apples from New Zealand or something like that, how crazy is that I'm getting apples from New Zealand? It is crazy, but you only get apples from New Zealand at a certain time of year. That's the time of year when they don't grow in the northern hemisphere, right? And it actually is cheaper if you're going to get apples to get from New Zealand than it is to get them from North America, where you have to add a lot of heat and a lot of sun power, sometimes through lights to produce the apples, right? So anyways, we trade a lot, and in the U.S., a lot of, we are self-sufficient now in oil. This is specifically trade of oil, but oil is still going back and forth. That's because there's lots of different qualities of oil. This is true of coal, it's true of natural gas, it's true of pretty much any energy source. I'm not quite sure about solar and wind yet, whether there's this kind of differentiation with those energy sources. I don't think so. But for sure with the traditional energy sources, and when you see sort of some of our oil going to South America, there are parts of our oil that go to South America. Let's take some of it and send to them because they can use parts of it that we don't use, even though I think South America actually is self-sufficient itself on oil production. But they're shipping some up to us as well. That's Venezuela shipping to us. So stuff is going all over the place. All right, just keep that in mind when you think about trade. It's really pretty much and this really drives a lot of what? What's this drive? This trade map. Drives a lot of what?
Like political relations.
Yeah, political relations, international relations. I mean, so interesting. Not so much for oil, but we'll talk about natural gas. And it's still a big issue even now. This sort of Nord Stream 2. What was it? I guess the Prime Minister of Ukraine is in the U.S. I think he was in the U.S. yesterday, today, something like that. Sort of talking to the Biden administration. What are they talking about? Well, they're still talking maybe about Trump because the whole deal with Ukraine and Trump. But the real issue that Ukraine is worried about is what? Russia, right? What's Ukraine worried about with Russia? They're worried about them coming over and taking over Ukraine. Why would Russia want to take over Ukraine? Yeah.
Because of their natural resources and like the sea and Crimea.
Okay, so they already got that part actually, right? So they already got the Crimean Peninsula. So they already got
And
that.
like the salmon river.
Yeah, so then they could get there just directly, right? Number one, but number two, really what they actually want is the transportation route to Europe, actually. So it turns out Ukraine doesn't have a ton of natural resources, natural gas itself. Russia has the natural gas, but to get the natural gas to Europe, they have to go through Ukraine. All right. So it's got this interesting situation where a lot of the natural gas from Russia to Germany, and Germany is heavily dependent on Russian natural gas, has to go straight through Ukraine. And so the Ukrainians, why are the Ukrainians over here lobbying basically the president? Fascinating situation because right now they're trying to build a pipeline from here over to here, come down into here. So I guess, I don't know if they're going all the way around here or something. For St. Petersburg, I guess it's actually right here. That would be St. Petersburg, yeah, right there. Really just a pipeline to come over here and come down into Germany to the Baltic Sea, right? And there's one thing stopping this pipeline, and that's the US, which seems odd, right? It seems completely odd that the US, and there's a whole story about this, if you get completely through this book by Jurgen. But it seems odd. The US is stopping this, but it has to do with the pipe and payments and stuff like that. The US happens to actually control. So the Ukrainians are over here trying to urge the president and Congress to maintain what is currently a congressional, there was a law passed by Congress that Trump actually signed that said that that pipe could not be used to put that pipeline in. I don't know why, it just seems odd to me that a specific set of pipe is the reason the US could tell basically a negotiation between Germany and Russia not to happen, right? So the Ukrainians are over there saying, yeah, don't let them build that pipeline, because if it does, then all of a sudden the Ukrainians no longer actually control the Russians' gas, right? It's kind of a fascinating situation, right? But anyways, this trade in these natural resources really defines a lot politically of what happens globally, and in a lot of ways, pretty much how governments react in those things, right? It's really controlled by the movement of this kind of stuff. There's this dream, this utopia, that if we could ever get to using just the sun and the wind, then in fact, actually, at least this part of the equation would be gone, right? That'd be great. And maybe that'll happen someday, but not right now. Okay, whatever. So now on to coal. Coal is interesting because why? It's different than oil. It's much more widely dispersed. If you look at where it is, this is just, we don't have to know the specific numbers here. But the point is this hasn't gotten much bigger over time. This was back in 2000, 2010, 2020, these approved reserves. But you can see it's kind of dispersed pretty evenly around the world. A few places have a little bit less. Basically, the Middle East and South America actually has a lot less. And Central America a lot less. So, but across the rest of the world, substantially pretty evenly distributed, and defines a lot of, their energy sources. I did not realize this, but in Brazil, in fact, actually, they don't have a whole lot of coal, but they have a massive iron ore industry. How do you suppose they produce all that iron ore in Brazil? What do they use? What was that?
Imports.
So they are importing more coal nowadays, but historically, they've produced a lot of iron ore. So how do you think they did? Up here we use coal. Europe use coal. What do they use down there? What does Brazil, think of Brazil, where they have a lot of trees? Trees. It's like they use trees basically, right? So back in the day, they cut down the entire Atlantic forest, which is kind of a novel ecosystem, and converted that into energy to produce iron ore. Today, they actually have a pretty renewable sort of natural resource. So they're not really using Amazonian trees. They're not cutting down the rainforest for iron ore, but they have a bunch of plantations. That's like 14, 15 million hectares of it, which is 30 or 40 million acres of plantations, trees, and it's basically a renewable resource for iron ore, right? So in fact, actually, if you get iron that's produced in Brazil, it's much more sustainable than iron that's produced anywhere else, right? Using coal. I mean, it's not the rainforest trees, right? So that's good. I mean, these aren't the most beautiful trees in the world to look at, but they're not coal coming out of the ground. At least they're sucking carbon out of the atmosphere and then going to put the carbon back up there, right? We go back there first. Yeah.
Are they using trees to make iron?
Oh, they're just using it for a heat source. So the iron is, still mined out of the ground, but then in order to create the actual sort of iron, to get it, I guess. I'm not 100% sure. We used to have these iron furnaces in Ohio. In Ohio, we have all these furnaces in Southeast Ohio. Basically, iron ore is in rocks and soils in southern Ohio as well. And so you basically heat this stuff up. And you can separate out the iron from the rest of the stuff. Put it together and cool it down. It becomes something useful, steel, I guess. Is that right? Any more familiar with this process than me? This is just a heat source, right?
Okay, I have two quick questions. One is, do you know if the land that they converted to the timber plantations used to be Amazon, and if now is it like pines? Is it just like whatever?
It was not Amazon, but it was the Atlantic forest, which is different. It's a different ecosystem, no less great, but this also was converted. I don't know if it makes a difference. It was converted 150 years ago, rather, last week.
But I guess the species composition has stayed
Completely
roughly the
different, yeah.
same. No, I mean like, in terms of like, once it was converted to plantation to now, like, are they just changing it based on what's the most profitable tree
That's
now?
correct. So the plantations today in Brazil are largely eucalyptus, actually.
Interesting.
So they come from Australia rather than pines from the US.
Also, why can't they use, why wouldn't they just use like oil or something? But you said that they have a lot of oil in Brazil, right? Or
They do,
have
they do.
all-
They've recently found a lot of oil. It's off the coast. They may ultimately use that, but probably not because they've got a pretty good thing going with the trees. And coal is actually cheaper to import than oil. Oil is more valuable to use as a transportation fuel
Okay,
rather than as a heat source.
so it wouldn't be more profitable for them to use that for timber exports or something? Use the
They do
wood.
export a lot of timber stuff as well.
Okay.
So they use the trees, the plantations for both heat for the iron as well as exporting a coal, basically. Okay, so coal. So who's consuming it? Well, who's producing it? Well, China, big producer. Rest of the world, big producer. India, start to see them come in, and the big thing in India is, everybody's question these days in terms of the energy sector and the environment is, what's this line gonna look like in a decade, right? The big turnaround here as a result of the pandemic. The big question is, India has about 1.1 billion people, 1.2 billion people. If income is something like equivalent of $4,000 to $5,000 per capita, China is more of like 13,000, 14,000. So if India were to increase the average income in the same way that China has, would we see this line way up there? That's the big question from the environmental side. And they probably have the resources to do that with respect to coal. Back to the page before. Coal consumption in the US and Europe are declining, which is a good thing to see. And production are also declining in the US and Europe. They're declining why? Why do you think coal production is declining in the US? Yeah.
The increasing sensitivity to like sustainability.
Okay, so we're consuming a lot less, and coal is an interesting thing. It's a great thing. It's a globally traded commodity. It's really easy to move from one place to another. And it just turns out that it's cheaper to, we used to actually ship a lot, and we still do ship a lot of coal to China and other places. However, it's just cheaper to get it from other places that are closer to China. Okay, so the competition has actually increased for coal.
I would say the discovery and like popularization of shale gas and shale oil. And a lot of people do that instead.
So, yeah, that has actually, that's exactly correct. So that has driven down consumption. So in consumption, we've reduced our consumption of coal for, in particular, electricity production in favor of using natural gas instead as a result of shale gas production. And that in turn is driving down the production of coal in the US. Because we're not using it domestically. Pretty much the main demander of any US coal is other countries, right? So our demand, overall production is going down. Okay, natural gas, who has that? So natural gas is very different, as we'll talk about. Although it's changing. So natural gas used to be really hard to ship from one continent to another. We're starting to see a change in that. So it used to be really important who had the natural gas. All right. So if coal, it was less important who had it in a sense because it could be shipped from place to place. With natural gas, it was critically important who had it because it was really difficult to ship from place to place. The only way to ship it really was by pipeline for many, many years until the last decade or so. We'll talk about this a lot later. This actually defined policy in the US pretty dramatically. You guys don't know it, but we really were a communist country for a long time. We had price controls for a lot of stuff, including natural gas for many, many years. It really actually affected natural gas markets in the US pretty dramatically and globally pretty dramatically. So from like the 1930s to the 1980s, and you're going to be really surprised when you hear who got rid of the natural gas price controls and who actually did it. But we had price controls where the government said this is going to be the price of natural gas, right? It wasn't a market, but it was the government, okay? And the reason our government did that was because there was recognition that natural gas was a critically important sort of natural resource, and we didn't have a lot of it, right? So they were really interested in what the government was. They thought they were doing the right thing. Turned out they probably weren't. Any of that, now that we've got fracking and hydraulic fracturing, we have a whole lot bigger sort of proved reserves of natural gas than we had before. Okay, so natural gas, and I mean, just compare these two, right? There's not a big change in the size of these circles in the last 20 years. Huge change in the size of these circles in the last 20 years. So we've really discovered a lot of big new reserves of natural gas around the world. Some that's been in North America, but the big chunks of it have been in other parts of the world, right? So it's kind of interesting to see. Natural gas proved reserves have increased. We're going to say coal hasn't. That's a good thing. It's environmentally better. As we'll find out, in producing 1 kilowatt of electricity, natural gas is about half as carbon intensive. So it produces about half as much carbon for the same amount of light. And it produces none of the other stuff. So, coal is famous for also producing a lot of sulfur dioxide, which is not good. A lot of particulate matter, which is really harmful for us to breathe. A whole lot of other volatile organic compounds, which are really harmful for us to breathe as well. It turns out that natural gas produces almost none of that when we burn it to produce electricity. So we still do have the carbon emission, about half as bad as what the coal carbon emission is, but almost none of the other stuff, right? So natural gas is overall just a better thing environmentally. Not perfect, it's not carbon free, but nonetheless, it's better than using coal. Trends in natural gas have just largely been up, a little bit down in Europe in the last few years, kind of stable to down in Europe. And that's because Europe has really pushed into a lot of renewables. And you can start to see the substituting renewables for natural gas. So that's great. So as we talked about, natural gas has become much more widely traded. This is going to become a really important thing, especially, I think, probably in the next couple of decades. What's this figure showing? So interregional pipeline trade, just showing how much natural gas moved by pipeline and how much natural gas is moved by LNG. So this is liquefying natural gas, the process of taking natural gas. How do you liquefy natural gas? We know how you do that. You want a chemistry major? Chemistry major?
No, but I know how you do it.
How?
Make it really cold.
Okay, just freeze it, right? How cold do you gotta get it?
It's like dry ice level, right?
Yeah, something like that. What is it? How cold is that? Minus 200 degrees? I don't know, something, some massively cold thing, yeah. Yes, you gotta get it really cold, all right? So you get it really cold, basically, in order to get into liquid form. And you gotta keep it cold. I don't know if the ships actually have to keep it cold, or once you got it compressed into the container, it stays cold. That's what I'm feeling. If it can't get out, it doesn't, get warm. So you get into a ship that way and then ship it from place to place. One of the big innovations we've had in the last couple of decades is that all of a sudden, whereas these terminals, these ports had to be really kind of constructed permanently, had to have a lot of technology with them. There have been some innovations where people have figured out how to off gas and stuff with a lot less technology. So whereas if you're a terminal like in the US where you're going to be taking natural gas and shipping it to somewhere else, in order to freeze it, it's actually a really complicated process, right? But in order to actually get it out of the transportation vehicle, i.e. the ship, and move it into natural gas form and put it into a pipeline, it's less complicated. And they figured out ways to do that, some innovations to do that are almost portable. Actually. So you can do that with basically these huge loading, not so much ships, but if you just think of some blow up mattress you might go way out on the ocean with, or the beach or something like that, right? The same kind of thing. You take and you create a big sort of blow up port, I guess, and you bring the ship into it, and you can pretty easily off gas and stuff. So you can imagine that if a country like Japan is suddenly in a really bad straits where they've got, something like a nuclear power plant that's just been devastated by a massive earthquake and tsunami, and they got to take the rest of the nuclear power plants offline, and they got to quickly ramp up the natural gas production. The technology like that is really great, right? Because they don't need to be producing this stuff, and they didn't need to import it. So you can have some pretty quickly movable technology that can allow you to import natural gas pretty easily and at a pretty reasonably low cost. Then you can have access to a sort of a resource that you didn't have access to before. This could be super helpful. And you can imagine this in the development process. This is also super useful for a lot of developing countries, actually, right? That don't have access to, a big source of natural gas. All right, so natural gas now is becoming much more widely traded. So that's an interesting thing. Also raises good prospects for, job opportunities and trading. This stuff is traded now around the world, not just, within sort of regions. So just like with oil, we have these sort of shale plays around the US, pretty much in the same places. Although, the one here, it's just kind of amazing that we're living in a place that is now one of the biggest natural gas producing regions of the world, actually, right? That just in the last decade, basically, this sort of Marcellus Shale, Utica Shale has become one of the biggest sources of natural gas production globally. Yeah, pretty phenomenal. Yeah.
Do other areas of the world use fracking as well?
Great question. Do other areas of the world use fracking? Yes, places are starting to use fracking. The evidence is that we are not the only place with shale reserves this close to the surface. So first to answer that question is that, Ohio is an interesting place. You see this short of Utica Shale keeps coming over, and even Columbus is in the middle of it. So in Columbus, it turns out the shale is really deep, like 20,000 feet below us, right? So the shale, the gas reserves in the shale, at least are that low. So the reason why all of the drilling for this stuff is further east is because that shale is a lot higher, closer to the surface, so it's cheaper. So at today's prices, it would not be economical for people in the central Ohio to drill down that deep for natural gas. 25 years, the prices are a lot higher than it will be economical, right? And so in some places in the world, the shale gas is just really Canada, other places that could really do something have it. But at today's prices, it's just not worth it for them to deploy hydraulic fracturing. Other places, there's other kinds of reasons why it's difficult to institute hydraulic fracturing relative to other kinds of natural gas production. So China, for instance, has estimates of pretty big shale reserves. But the difficulty is the pipelines, right? So with private property rights in the US, what sounds like it might be difficult to actually, figure out a way to put a pipeline together, but because we have all these right of ways going across land anyways for electric, for gas lines that exist, roads, et cetera, et cetera. It's actually not that hard to put together this collection system to collect the natural gas from this highly disparate sort of shale gas operations. You saw them in the picture before, right? And these are small drill pads about the size of this room. They go double the size of this room, all right? And you have hundreds of these across the landscape, and you have to collect all the stuff from those in a pipeline and ship it somewhere. So it turns out because the U.S. has a pretty good property rights system that really allows you to put together and profit off of the development of a transportation system as well. It's actually been really easy to put together shale gas production in the U.S. It's harder in other places, right? It's easier in other places to put together massive projects where one well, one drilling produces a lot of stuff, and you don't have to put together the same infrastructure around it. And so it's interesting that shale gas does seem to be uniquely suited for the U.S. At this moment at today's prices. As prices go up, I mean, you can imagine if you're China and you need natural gas, then this is not an insurmountable problem, figuring out a way to collect this stuff, right? Just maybe it doesn't work right now because you can probably import it relatively cheaply from Russia. In fact, you can. All right. But if the price of natural gas starts to go up enough, then this is not a problem I imagine China will have trouble getting around. They'll figure out a way to get around this transportation problem. And as the USGS has estimated their reserves at pretty significant levels, actually. So it's there, it's just a matter of whether they get around it. Same thing in other parts of the world. Europe, Europeans have potentially a large amount of shale gas as well. But again, there's lots of institutional reasons why they have not gone and gotten those. Yeah.
Might be a stupid question, but if natural gas is like, half the carbon emissions and doesn't emit a lot of other things, and why is fracking so unpopular?
Well, fracking itself can be dirty and can lead to other environmental consequences. There was just a case in eastern western Pennsylvania where it's a pretty large case, several tens of millions of dollars just to get them to pay a bunch of landowners because they actually did harm their wells, their water wells in rural areas. So, so there are other kinds of concerns, environmental concerns associated with hydraulic fracturing. Most of it has to do with the disposal of the waste that happens. So, we'll talk a little more later about how to do hydraulic fracturing. Basically, you're drilling down into the ground. You then do some controlled explosions down there, and then put a bunch of chemicals in the ground to help keep the shale open. So you're trying to break open or fracture the shale to let the gas come out, and you put down a bunch of other chemicals and sand and other kinds of stuff that to basically try to keep the shale from collapsing again, to allow the gas to come out. But then those things come up with it, right? And you end up with that stuff and the gas on the top of the surface, and you have to get rid of it. So it's a waste that you have to get rid of. So I mean, so there's other reasons why people don't like hydraulic fracturing, but the reason why it's really gone ahead is because we've been able to, I think people sort of recognize that those are issues we can deal with, and the benefits of the cleanness of the stuff when it burns is outweighs that. Yep.
Can fracking cause changes to like supply and just like variations in like rate and stuff?
Yeah, so there's my understanding is, so the question is can fracking cause sort of harm on the landscape? Maybe we thought that. My understanding is no. That the fracking itself, because shale, you're really displacing small pieces of it and then it crumbles together back down. You're not displacing a lot of earth or moving a lot of earth. Where there have been troubles is in these chemicals that people use. One way they get rid of them is they inject them back in the ground into deep wells. So they go deeper than the shale. and they inject the stuff in the ground, and that has been known to cause earthquakes and other kinds of problems. So it's the injection of the waste in the deep wells, which seems to be a bigger problem, actually. And can cause not so much, changes in the Earth's surface, but can cause earthquakes, which can create a lot of damage, right? So that's my understanding of it.
Doesn't it also have a very, very high chance of polluting nearby water sources, which are typically like low income and minority groups?
Yeah, I don't, in terms of the disposal wells, you mean?
Yes. From
Yeah.
the leftover aftermath of fracking.
Yeah, so the disposal wells, the injection wells, I don't know that they happen to occur more frequently in cities than they do. I think most of them are across the countryside. I don't know, Ohio has a long history of injection wells, in fact. Because we have a large industrial base, it's not surprising that industries in Ohio have been trying to get rid of plastic and crappy stuff for centuries, right? So they've been. It surprised me, but I went to, it's when I first got here, I remember going to some geology seminar. And this dude was talking about injecting caustic crap into the ground. That's weird. Why are we doing that? And it's because they just, what else to do with it, right? It's better to stick it 20,000 feet down there where you don't know what's going to happen to them. It just seems weird to me, but whatever. So this is a long history of doing this, right? And when fracking came along, we just did more of it. Does it harm water quality? Mostly this is down in the area where we would not be pumping water for drinking water. However, on the way down, it can cause water quality harm. That was part of the problem that happened in Pennsylvania. So, and it was people who were relatively less well off than the average person who were harmed by that, for sure. I don't know that these kinds of harms are any more inequitable than other kinds of environmental harms. I don't know.
Do the power plants themselves produce more pollutants than the actual fracking sites?
Yeah. Well, historically, yes. Coal burning power plant historically was a pretty nasty thing. And I mean, the list of things from a coal burning power plant is pretty broad. So sulfur dioxide, nitrogen oxide, volatile organic compounds, particulate matter, mercury, PCBs, you name it. So pretty much everything comes in. You burn coal, you get all that stuff. Natural gas has almost none of it. So in terms of the use of it for electricity production, for sure, coal is substantially more. And large coal burning power plants, say the ones in Ohio, that exist along the Ohio River, still exist some of them today. And they're enormous. I mean, they have produced as much carbon dioxide as entire countries, really. So, but we're a lot better off than natural gas. Yeah.
Does the general public opinion of fracking have anything to do with how it's escaped many of the federal regulations of EPA? It's not monitored under the Safe Drinking Water Act, it's not monitored under RCRA, Clean Air, Clean Water Acts. It's still regulated by states, but does that have anything to do with its perception?
Yeah.
It seems better. Do you see what I'm saying? Maybe I'm not being clear.
Well, so it is. Well, it's fascinating. So it is regulated under all those things. So in this class, and we've had the direct negative to come in, the direct EPA, and I've had Scott Nally, the previous director, several previous directors have been in here. They would always argue that in fact, actually, it is regulated. So they do regulate that. Provisions of the Clean Water Act, the components of it, and RCRA, which is the Resource Conservation Recovery Act, which pertains to cost of crap, right? So they would argue that it is, right? So it's a legitimate argument as to just how much it's regulated, right? So there are concerns that it's not regulated. So I had the governor of North Dakota in the class, 8 years ago. North Dakota being the Bakken, the sort of center of this, and he basically said, we spent the first decade because we just wanted this industry to grow, not regulating it. He was pretty honest about that. You said we weren't gonna regulate, I wasn't gonna have my EPA, I don't think it's EPA, I think it's Department of Conservation or something like that in North Dakota. But you said we weren't gonna have them go out and push these regulations, because we just want to develop that industry first, so. So I can see what
I
you're
was just
saying,
curious, I was just curious, thank you.
yeah, I can see what you're saying, people worry about that as an outcome. So. Yeah, in Ohio, I think, yeah, Ohio's a fascinating place, so, well, just as for everyone's information, so that the Clean Water Act is a federal regulation, but it's delegated to the states to implement, so the states actually implement that law. And so the state of Ohio has a lot of authority. I think that's kind of what you're referring to. States have a lot of authority to implement the federal regulation to the extent to which they want to. And for sure, Ohio has probably spent less effort, significantly less effort than New York State, because New York State just decided they didn't want fracking and they regulated it out of existence, right? Pennsylvania is kind of in the middle between New York and Ohio, and they've regulated a bit more, which is what's led probably to the lawsuits that have actually created a situation where Chesapeake Energy has paid significant amounts of money to local landowners for harm, right? Ohio's probably on the more on the North Dakota side of that. I don't know if that answers your question.
No, it does, I was just curious, I didn't know if that had any impact on its perception.
I think the perception has more of an impact on how people regulate it. So I think in Ohio, the perception is fracking is generally, this is a general perception, not my opinion or anything else, the general perception of people's perceptions is that people generally think it's a good thing, and that probably influences how heavily we regulate. I think it's actually the other way around. I don't know. Question.
My family lives in a farming community in like northern-ish eastern Ohio, there's fracking and everyone hates it.
Okay.
Because it like upsets the livestock and also if they grow a lot of corn. there's not much choice. For
Yeah. Yeah, it's interesting. So that's good. I mean, I think the general experience in rural communities has been a very mixed bag, right, with respect to hydraulic fracturing. That some people love it, some people hate it, right? You would agree that you say most people hate it.
Well, just from my experience.
Yeah.
Like, wow, people that live there, it's not around anymore. It like upsets their farmland and it's bothersome, so.
Yeah.
I don't necessarily strong opinion.
Yeah, it was interesting. I mean, because this new issue's blowing up with respect to solar panels as well, right? Throughout rural areas, because a significant chunk of acreage. So I've estimated that between the collection pipelines and the actual frac pads in Ohio, there's about 50,000 acres of farmland and forest that have been converted over to fracking related resources. Solar, if it goes in the direction of the existing proposed solar facilities, would have 60,000 acres. So slightly bigger area of land. Now, it wouldn't have any of the, as much of the sort of industrial component. It's not gonna have as many trucks running across the landscape as frequently, right? You're not gonna have a sort of drilling process, et cetera, et cetera. You're just sort of putting the solar panels in and then leaving. But it seems to me, just based on everything I've read, is that there's no less concern in rural areas with solar actually going in as with fracking.
My grandparents live in like Van Wert County, so one of their biggest things that they hate right now is actually like wind.
Oh, true, midterm. That
It's
was
like they're like, wow, like road scenery, kills a lot of birds, stuff like that. So I think a lot of things in terms of energy, even if it's renewable or not renewable, has pretty bad consequences.
Right. Yeah, so wind in Ohio, wind power is done in Ohio, right? Because we have this new setback regulations. So one of the things that the state put in place, because of local opposition to wind power after the big wind power facilities in Northwest Ohio went in. There's a couple more that might go in because they're already through the Ohio Power Siting Board, but they may not because of local opposition need to go in. But so Ohio put into place setback regulations that said that you can't site one of these things within, I forget what, 200 feet of a home, school, something like that. which really kind of says you pretty much put them nowhere.
Sir, I was just curious if you knew whether the proportion or ratio in terms of energy derived from solar and then natural gas, like the comparison between the two, and if they're like substantial to support our energy needs.
Well, that's really gonna be the rest of the class on this, but yeah, so I can actually show you that. So this is fracking, just a second, we're actually get that, exactly that. So this is fracking in Ohio. It's just exploded. Renewables, the US. So you've got US, Europe, China, India, the rest of the world, really starting to grow. So it's really just exploding throughout the world. And just to prove the US is not really so much of a laggard, a little slower nowadays, but probably this is going up at similar rates to everybody else's. You can see what kind of renewable these different places have instituted. So the US, other is mostly biofuels, which is mostly corn-based ethanol. Should use the transportation. Wind is a big chunk, but now solar is a big growing thing. Europe's interesting. They also use biofuels, but that's all basically use of trees to produce electricity. So they have a different kind of biofuel than we use. Also big chunks of wind. Most wind in Europe is offshore. Most people think that wind power is going to have a future, it's all going to be offshore. So that we're in Ohio, we're going to see it. It's not so much on the landscape anymore, but offshore in Lake Erie potentially. I think the environmental groups in the state of Ohio came to an agreement to put in one windmill out there, somewhere off of, I think up at Cleveland somewhere. And we'll see how it goes with the birds and other kinds of stuff, because it's a pretty big migratory pathway through there, and there's concern for those birds as they fly through. So I think that's going to happen. And if that is successful, then we should see a lot more wind power in Ohio, at least offshore, because you can get 200 feet from houses and things like that. But very little of it onshore. The big thing most people are excited about on renewables is happening here is solar, right? It's a huge growth in that. And lots of expected growth in the future. So where are we going? So this was just kind of an outlook thing we looked at, is that solar becomes a new king of electricity. So this is the exciting part globally, is that solar prices and costs have gone down so dramatically in the last decade. And it's just really cheap to do. And we're seeing a lot more of it get instituted both here in the US and around the world. We'll talk about 1888. Seems like a long time ago, I know. What happened in 1888? Anyone know? $1859. We got to teach you guys about history. 1888, Pearl Street Station. So it was the first central station power production in the US, right? So, and they lit up a block of streets in New York City. What was this recent movie? You guys see that recent movie? What was it called? Great movie. I just got to see that. Maybe we'll watch the class. We'll just give up class more today. Probably learn more from that than me. Anyways, now basically, it's sort of BC, AC, which one was going to be the winner, right? Westinghouse versus Thomas Edison, right? Tesla was in there, the whole thing, right? It's great, great movie. Go look at it, go watch it. As soon as I figure out what his name was, I'll let you know, right? But the great thing is, if you go back and look at that, in that time period, it was an amazing, amazing set of changes. We basically invented electricity and got 90% of the houses in the US connected within a 30 to 50 year time period. So it's pretty fast given how old it was back then. I mean, we're going through something even different than that right now. It's even faster, right? So this movement to solar and this potential change to the grid in the next 25 years could probably rival that 50-year period, right? I mean, just imagine how amazing it would have been if you had no access to electricity, if you're using a whale oil. I mean, imagine that, or kerosene. I mean, shit that can blow up, literally blow up your house, right? And all of a sudden you've got lights, you can turn them on, and you can do stuff all night long. Because you don't have to go start the fire yourself, right? I mean, it's kind of amazing back then, right? We're kind of going through the same thing potentially with solar power right now. The transformation is literally happening that fast, right? Not just here in the US, but around the world. So this is kind of cool, kind of living at a time that's just kind of rivals what your great grandparents maybe experienced. So kind of cool. We're not sure what the pandemic's going to do. This is really kind of twisting things up. So you'll see that come back a lot in our discussions this year because we're just trying to figure out the data. And then what's going to be the trajectory from there? Right. So the pandemic really kind of messed things up, and no more so than this electrification in Africa. So there was this amazing trend towards increased electrification in Africa, partly driven by solar power. Right? People had. This is the thing, like with cell phones, right? Think about why we have crappy cell phone communication here. Why do we have crappy cell phone communication? Why does it not work so often in the US? It's better now than it was a decade ago, but well, part of it is because we have this whole history of having put landlines up, right? So if you're a new competitor, you're coming in, you're putting up these sort of telephone power, these telephone poles for, I guess for smartphones and cell phones. I mean, you want to concentrate them in certain places so that you can make the most money, realizing you've got a competitor, which is the person who has access to every single house, right? At some time, everybody had access to a telephone line. Still do actually in the US by law, right? All right, if you're in someplace like in Africa or Latin America where they've never had telephone lines, then it's easier to put up a much better distribution system for cell phones, right? So lots of places will have much better cell phone sort of technology, I should say, ability to connection to connect to the system than we do here in the US. Maybe it's the same thing in electricity, right? I mean, parts of Africa have been without, parts of Latin America have been without electricity forever. But now with solar panels, it's a lot easier to get electricity to those places than it would have been to have a central power station 500 miles away to deliver electricity via a big old power line, right? So all of a sudden electrification, and it was actually because of the fact that we were driving down the price of solar so quickly, and also partly because people were moving into cities pretty dramatically in Africa. We're starting to see there's a trend there towards an increase in electrification. It really slowed down in the last year. Huge concern that this may slow down dramatically going forward. That's a problem. Another thing, peak oil demand likely to happen in the next 10 years. The speed of decline in demand. It's set to see. So peak oil, yeah.
I have a question about that. How like certain are the experts, I guess, about peak oil demand happening in the next 10 years? Because like, if you look at a country like the US, we're still demanding more, or I mean, at least we were increasing demand for a lot longer than just 10 years. And like developing countries are going to continue to develop for a lot longer than 10 years.
Yeah, this is the race, right? This is the race. This is the race between efficiency improvements in the developed world and rising demand for transportation in the developing world, right? So that's kind of related to this, right? So the year before last, I would have said 10 years, no problem. Simply because we are seeing incomes rise so rapidly in the developing world. People are moving into the middle class rapidly. So there's a big drive up in demand for driving cars and things like that. But we're also seeing massive increase in income in the developed countries that was driving down the demand for transportation, traditional transportation fuels. And it looked like that what was happening in developed places like the US was happening faster than in the developing world. So we were actually hitting a peak globally. I don't know what the pandemic's going to do, right? It's hard to tell because it's taken us off the trajectory of the way incomes were growing before. So I don't know. You know what? This new one, this 2020 sort of world energy outlook seemed to be less optimistic. Last year, they were much more optimistic about peak oil demand happening within the next decade because what was happening in the developed world was really happening as rapidly as what was happening in the developing world. But we'll see. It's a good question. Did you?
Yeah,
comment?
Yeah, hopefully this is not too off topic, but how far can we transport solar? I guess like what I'm trying to say is, could we ever solve intermittency issues like in America, for example, by like simply just redirecting the flow of solar energy from like Nevada to like Washington when Nevada has a very sunny day and Washington's very cloudy, you know?
Yeah, I mean, we already do transport wind power and solar power over private business distances for sure, right? So it doesn't mean that those exact electrons are making it that far, right? But with our electricity grid, when we get into the electricity grid and start to see how it's constructed in the US, you can see that this, we can move the stuff pretty far. I mean, we have an interconnection that would allow wind power from Texas to get to Ohio, for instance.
So could we transport it internationally then?
Well, you'd have to have electric lines to do that at this point in time, right? There may be other ways to transport electricity, the same way we do talking to each other on a cell phone, right? Electric ways to travel through the atmosphere. There may be ways to do that in the future, right?
If so, if we could do that, do you think that would be a big boost for the solar industry? Do you think people would be much more interested in investment? Like if we could transport it more quickly, faster?
Yeah, that's what you're saying, because the sun's always shining somewhere.
Yeah,
Yeah, for sure. Yeah. Those technologies are pretty far off, I would imagine, though. That's a good question. Yeah. That's one benefit of living around Earth. Thank God it's round. Yeah.
You guys are solar currently, that's why it's like we have to have roofs, or like the grid has to be right by the plant. Because the solar has to go right until the grid's being utilized then, correct? Like we actually haven't figured out technology to transfer it yet, or have we?
No, we can transfer it, but the issue really with solar and wind is the storage issue, right? That it's intermittent. And our need for the electricity happens at a time when the wind's not blowing, so ultimately that's what happens, right? So, we need some sort of a storage. Or as we're talking about, what we use right now is sort of on-demand stuff, some sort of natural gas burn or something like that to come on.
Just spitballing. But it's interesting how like it's better for our bodies as human beings to be in flow with our circadian rhythm. So going down with the sun, waking with the sun, and how that could correlate with better use of like renewable energy sources like solar.
That's true, but we've been in this, lifelong, human existence long effort to try to get the Earth to follow us rather than us follow the Earth. And why don't we want to switch it around? Agriculture, 10,000 years of it, at least or more. I don't know, it'd be a tough call to go back to and just go with some of the Earth. Be nice though. I'll tell you what, when I went to sleep the other night at like 6:30. I woke up the next morning at like 5. God, I felt great. It was awesome. 6:30 is not dark right now. It is in the time. I was sitting back.
So on the first bullet point, it's talking about the cost of solar, how it's come down. Plus an idea of like how much it would cost in 2010 versus if you install solar panels on your home, like what would it cost then, what would it cost then?
Yeah, well, this is I would say probably like 80 to 90% cheaper today than it was back then, so almost half the price. That doesn't mean that it would be worthwhile for a capital investment for you. You're probably still better off actually just buying electricity from the grid. Remember, because it's still a capital cost up front that all that installed, right? Which means you got to pay $20,000 up front and get it paid back over the next 6 to 8 years. So you're still probably better off economically, but maybe not environmentally, just buying power from the grid. But it's cheaper now than it was before. But no one did it before because it was super expensive, and now you see this stuff popping up everywhere because it actually is cheaper. So, any other question?
Well, I think like a big reason why it's so cheap is because of like large scale, there's a lot of like government subsidies and stuff like that. I was wondering if you thought that like at some point the government was going to say let's stop subsidizing this and use the money somewhere else. I think that's gonna like drive the prices up.
Yeah, so, I think the production tax credit, which also extended to residences, is gone now. I don't know though, because we just, with the new infrastructure bill, I think there might have been something in there that actually extended it a little bit longer. So for sure, the production tax credit that we'll talk about and see data on later is a really important part of the emergence of solar and wind as well. And it drove the early part of those industries. But right now, those production tax credits are they're basically gone now. So any new builds of solar. Now, this is unless the infrastructure bill recently actually extended them. I just didn't read the bill that closely to know. So, it had an impact, big impact, but the costs are so much lower now that it probably would not impact anyone. Probably wouldn't make the difference between more solar versus less solar. And the other thing is that natural gas and coal actually face environmental taxes for the externalities that they cause. And coal is actually really cheap, if not for the fact that you have to do all these things to clean the stuff up before you use it, right? So all that mercury, all that PCBs, all the nitrogen oxides, all that sulfur dioxide, all the crap that comes out when you burn coal, that all has to be scrubbed out of the flue gas before they go into the atmosphere, right? And that's really expensive. So that's actually raised those costs as well. So, we've kind of done both things, raised the cost of dirty stuff, and we had for a time some subsidies for the clean stuff. We did push those industries to go further along. But the other thing that happened was that China decided that they really wanted to go full hard into the production of solar panels. So it's not just that the solar panels became more efficient, it's that the production of them got really cheap. Right? So this competition that China sort of started by diving into the production of solar panels and getting really good at it, forced other countries like the US to get really good at it as well. So it really drove down the cost. So it's not just that the technology got better, but as with all technologies, over time, the way we produce these technologies gets better and better. And so we're able to produce them at scale much more cheaply over time. So that actually has driven the industry to a point where it seems like it's kind of got a life of its own. Geez, if you look at Ohio, literally, there are, we'll look at maps on it later. There's 60,000 acres slated to go into solar panels in Ohio in the next 5 years. This would be 10% of our electricity. This would be a huge change in our electricity consumption and production in the next 5 or so years. So, and this, was driven at first again by, to some extent, by the production tax credit, but more so by just the massive reduction in costs. Remember, Ohio has no actual regulation that says you have to do this, right? It used to. We used to have renewable energy standards that really required it, but we don't have it anymore. So it's kind of interesting. I've never experienced this. This is amazing. You guys are amazing. Just do tell me that this will stick up. Just no. Usually it's tough. No one ever asks any questions. It's awesome. All right. So don't stop. You can stop today, but don't stop in the future. That's good. Because I haven't got to my freaking slides anymore. I got what am I going to do? I got another. I'll have to extend another quiz deadline, I guess. I don't know. Have you ever seen people like professors do speed talking just to get to their slides? Do you want me to do that? That's fun. I'm just kidding. Okay. Well, so rather than speed talking, I'll just flip to the slides. How's that? Better? Okay. So, one philosophical thing that I really did want to just re-emphasize is that one thing I don't want to do is, I'll just use an example, right? We all complain about climate change and the fact that there's settled science on climate change, everybody should just believe it. So my belief with something like climate change is that I would much prefer if you guys and this is anyone, not just you guys, but people, were able to go out and collect the data themselves, right? And answer the question themselves about it, and just take it for given that this is what science says, right? So in other words, I'm not going to sit here and try to convince you of anything related to the energy sector or anything else, right? I don't really want to convince you of anything. But what I really want you to be able to do is at the end of the class, be able to go find the data to convince yourself, right? So, and to know what a good data source is, and then be able to put the data together in a way that you can convince yourself, at least of the economics of it. So and what goes with that is if I say, well, shit, solar power has gone down by 70%, you should always question that. Or I say the production tax credit doesn't, fine, question you, that's fine. Because that means you're gonna go out and look up the answer for yourself, maybe, right? Because I think it's always good to do that, right? So I'll try to give you maybe my best impression of it, but remember, I'm just using the same data you have access to. And I'm just interpreting it my way. And I'd love to hear a different interpretation, right? So if you do think that something I'm saying, doesn't fit with the data, doesn't sound quite right, I mean, feel free to question. That's a good thing, right? Okay, so that was whatever philosophy. Did we read this one this year? Which one did I have? IEA one, right? And it was the one that wasn't very well put together, right? It repeated itself like 5 or 6 times. I noticed that. I tried to fix that a dozen times. But on the website, it actually repeats itself too. So it was the most weirdly constructed thing, but it had some nice things that said in there. So I thought it was useful. But those of you who are looking at the PDF and wondering why is this thing so messed up, that's the way it came. Sorry about that. Could see increased cyclical activity in prices. So in the last class, kind of said, well, probably fracking could lead to smaller cycles in prices. Well, these guys are actually arguing kind of the opposite. They're actually arguing that now all of a sudden, we're in kind of a different world. So the market value, the capitalization value, the big companies, Exxon, Mobil, Shell, et cetera, their oil and gas assets are worth 50% of what they were worth a few years ago, right? Which, if you're an environmentalist, is a great thing. I mean, what was the big thing last year? Exxon Mobil got thrown out of the Dow Jones Industrial Average, right? They've been in there since the very beginning. In fact, they were the only company that had been there the whole time. Wait, there's one other company. Procter & Gamble. Yeah, there's one other company that's been there the whole time. They P&G. So, but Exxon's been there forever, right? But they were thrown out because their market value went down so much. Dow Jones didn't think it really represented enough of society's sort of stuff that they demand anymore. It's kind of interesting that way. But the argument in this IEA is that could actually lead to more sort of uncertainty in prices and fluctuations in prices. So we'll see what happens. I kind of think it'll lead to less in the long run, but that's kind of their statement. If the energy sector continues to operate like today, temperature increases will be 1.65 degrees. We're trying to get everything below 2 degrees, right? Around 1.5. So that's if the energy sector continues to operate like today. Of course, it's not going to operate like today. It's just going to get bigger and bigger, right? So that's why we talk about that being bigger than 1.65. Yeah.
1.65, like that. By 2050 or like.
Yeah, just between now and the 2 train times.
Oh,
We can get above 1.65. Above. We're already 1 degree above where we were. 60. Everything's measured relative to 8 and 60, basically. So it's another 0.65 over the next year. We're at 30 to 50 years.
And that's if we don't grow at all, like.
That's if it
no
just
more
stays the way
demand.
it is, yeah. So it's likely to grow. So reaching net zero by 2050, this is the big one, with 40% reduction in emissions by 2030, which is what we require to keep us below 1.5, basically. Just think what you have to do. 75% of global electricity generation. I thought I had to shut up and it would disappear, but I guess I have to just keep talking. Provided by low emission sources up to 40%. Obviously, I had to get that out before. So I'm saying it's not bottom line. You can see it from the this mask sucks. Whatever. That's a big ask, 75%. That's a lot of energy. By 2030, when's 2030? That's like 9 years away. Shit. More than 50% of cars sold are electric, up from 2.5% today. Oof. You guys can buy electric?
What's technically counted as low emission?
What's what?
What is this, statement counting as low emission source? Is that natural gas and then renewables, or is that other things?
That would not be natural gas.
It's just renewables.
Well, it could be natural gas with carbon capture and storage. So you suck the carbon out of the gas when it comes out. Just a little bit of it, so you're not gonna get all of it, right? You could make it low emissions, you know. But it wouldn't be just the way you do natural gas right now. So even though, yes, a good question, even though natural gas is a lot lower than coal, it's still high relative to obviously solar or wind or renewables, or I should say biofuels. So burning trees, right, that's a big emission, but then you're regrowing the trees, so it's actually zero emission in the long run. Okay. So that's where we're going. BP is kind of similar, basically saying the same thing. The point of this was just to point out that these different organizations really kind of come to some similar conclusions. The world's going to continue to electrify. So everybody's looking at electrification as being the big sort of thing that's happening. And then if you want to really get this 1.5 to 2 degrees centigrade thing, we're going to have to electrify really quickly. We're going to have to get the transportation sector over to electricity really quickly. You know, so they're sort of saying that the demand for oil plateaus, right? That we're going to hit this sort of peak in 2030s. I mean, it's fascinating that an oil company is saying that, right? They're basically saying that our bread and butter is no longer going to be a big growth industry. It's no longer a big growth industry today, but by 2030, it's going to be on a decline, right? That's kind of a big thing for a company like that to say. You know, strategically, then you've got to figure out something else to do, right? If you're going to remain a Fortune 500 company, then you have to do something else besides oil, right? So they're figuring that out right now. Yeah.
That's what I was gonna ask. Do you know of any like major investments by some of these companies? Because if they're acknowledging that, you know, their revenue source is gonna be gone and they have all of the money from oil to invest, are there any like huge investments from these companies in like solar power or anything else?
Absolutely, yeah.
Okay.
They're making all of it.
Oh, okay.
Solar power, wind power, transmission. Yeah, they're recognizing that, and AEP is in this competition as well, and they're recognizing that, you know, well, take Ohio State as a business. A place like Ohio State has its consumer base of students who wants to see it be green. So in order to manage that, you know, Ohio State can try to have a whole sort of set of people who do that themselves, or they can turn it over to AEP, right? And AEP can, you know, put them on a pathway towards green energy consumption within a decade or something like that, right? So they're trying to specialize in management of energy for companies. You know, that could be for Ohio State has also a transportation fleet, right, to deal with, which maybe you could engage a company like BP, right, because they're a transportation fuel oriented company. But I think bigger companies like United Airlines or American Airlines, you know, how are they going to do this, right? So they have to manage the transportation fleet on the ground, right, moving all these trucks at the airport that move from place to place, along with the airplanes themselves, right? So this whole business of, you know, sort of logistics, strategizing, you know, how do we move towards this sort of renewable era? You know, these companies like BP are thinking that, well, the United doesn't want to do that themselves. They're going to hire us to do it. They're going to pay them a boatload of money to do it. So that's, as I understand it, you know, there's a video. I think I might show it online in class later, but there's a video of the sort of current BP president basically saying that's what they're trying to do. Natural gas consumption will continue to increase unless new policies are introduced to increase. Unless new policies are introduced to increase the use of renewables. So, you know, these oil and gas companies are saying, and this is going to continue to increase. They're probably going to stay pretty heavily invested in natural gas. But they're going to pay close attention to policies by countries, right? So these are things like what Germany has we'll talk about feed-in tariffs later that help subsidize the use of, you talk about subsidies for solar. I mean, these guys have huge subsidies for solar in Europe. So policies like that would be the kinds of policies that would promote renewables, right? And increase the competitive balance towards renewables relative to natural gas. So BP is basically saying there's a massive supply of natural gas out there. This would be the preferred thing that people would use. There's lots of electricity globally. However, if you're going to price the externality or you're going to subsidize the renewables, then that could actually shift the balance towards away from natural gas consumption towards renewables, right? So BG is just saying, yeah, we got to watch policy. That's what they're saying with that statement. You have to watch policy. You have to see what countries do, right? And pay attention to what things like this. I don't think the Infrastructure Act that just was recently passed in Congress had much policy in it other than what to build, right? I don't think it actually. I don't know. I'm going to go and see if it's promoted. Coal consumption is already plateaued and continues to fall globally while being slowly. So they're saying that coal's already gone over the corner. And then hydrogen is going to increase. Oh, BP is big on hydrogen. So this is a big thing. So hydrogen, wow, this is some fascinating stuff. How do you transport hydrogen? Okay, hydrogen can be used both. You can use it in cars to move cars around, right? You can create basically electricity out of it. I think that's how you propel the engines. I don't know, hydrogen maybe propels directly. Anyone know that technology? Yeah, I'm not sure how it moves a car around. Think about that. The hydrogen is a really dense energy source, right? And it's carbon free. How do you move hydrogen from one place to another? Really innovative here.
Liquefy it like natural gas.
You can, but it has to get, excuse my language, a shitload cooler. It's actually more expensive.
You still liquefy it?
And this is just a guess, but like water, would you move it around? In what, in the form of water?
You can, but it's also expensive to move around because it's heavy and not dense. That in that form, it's not a dense energy form. Of hydrogen, it's not. And then you have to get it out of that form, actually. Okay, so ammonia. Everybody remember ammonia? Yeah, ammonia basically is hydrogen in it, right? So basically, you know, this they're shipping hydrogen now. So British Petroleum was involved. It's a huge shipment of this stuff called blue ammonia from Saudi Arabia to Japan. Again, Japan needed the energy, right? But you can put it in a big ship and move it from place to place. So it's actually a way to take energy and move it from one place to another pretty easily. Like we're talking about with natural gas, pretty simply, and can lead to a part of source of energy. Yeah.
It's kind of like maybe far off, but if people just give it up on like fusion reactors as being like an energy source.
Yeah, you don't hear a lot of discussion about fusion reactors. Yeah, I think because they never found a way to get the fusion reaction going without a lot of energy. But I think that's my understanding. I don't know for sure. Anyone knows more about it. Yeah.
Yeah, I actually just watched a video on it that like, there's like 2 big labs that are still working on it, but like, it is super energy intensive and they are hopeful, but like, it's more just kind of almost like a science experiment. They're just gonna keep going and see if they get it right or not.
Yes, it's these accelerators, right?
Yeah, like the big
one in
magnet
France
things.
and Switzerland, and there's one in the US somewhere.
Yeah.
Yeah. Yeah, so I think, yeah, it's kind of way off in the future. Relative to the other things. But maybe, you know, maybe 50 years from now, something like that. Yeah. Okay, well, good job with questions today. So there is a quiz due tomorrow, right? We'll talk about the game on Thursday, and let's see, Bruce will come in next week. There's the quiz for this week will also be due on Wednesday next week. Okay, so I think what I'm going to do is just switch the quizzes around to Wednesdays rather than Sundays. There should be tendency to get behind a little bit. So I think that'll help out a little bit. And then homework is in a week and a half or something like that. Okay, so Thursday, we'll talk about all the stuff you need to do. Now, also online, just the final thing, online, I put in, I just put the stuff up from last year, it's all there. It was online last year. Feel free to use that, you don't have to use that. If it's useful, use that. So that's the kind of stuff that can help for the homework, et cetera, et cetera. But we'll do the stuff you need for the homework in class as well. So in principle, you know, you can get everything you need from almost from the web, as well as from the class. We've done those. So you guys can kind of pick which helps you the most, all right? And then maybe later you can tell me which helps you the most, right? You know. Okay, so awesome, good job. Thanks for all the questions. We'll catch up on Thursday.
To be clear, the quizzes are open book, right? Okay. Yeah.
The quiz due at 11:59 p.m. or 8
I think so, yeah.
a.m. Okay, I just want to make sure. And also, I've
It says PM, no, it's till PM.
no, it says a.m.
Okay, yeah,
Yeah.
it's just, I meant till noon.
Yeah, no, that's fine. Also, I'm in SLDS, so I just want to make sure I got the extra time for it.
50%.
Okay.
The extra 50%.
Yeah.
Double time.
It's I get a time and a half, so yeah.
Yeah, I haven't done that yet, but
Okay, it'll go in.
yeah, you know, I should get that in tonight. Yeah.
I'll
So
take
I don't think I'll get to it till tonight though, so
Don't take it till the morning.
I don't think you're gonna,
Eat it.
honestly, I mean, it's 10 questions, it's 60 minutes
Okay,
anyways.
then yeah.
But if you take it, if you feel like you want to take it tonight and I haven't done that, feel like it's a problem, just let me know.
Okay,
Okay, just email me.
all right.
But you know, I imagine it'll be fine.
Yeah, sounds good.
Because these quizzes, yeah, like
Yeah,
they're
I saw
60
it was 10
minutes.
questions, so I didn't know if I already had it.
It's 60 minutes, yeah, so it's plenty, it should be plenty of time, but I will double it, I will, or 50%. I'll
Thank
get,
you so
but I
much.
can't do that until probably 8 or 9.
Okay, that's fine.
Okay.
Thank you.
Hey,
Hey, so I was curious about the lecture slides
Yeah.
in general. So I noticed that the ones we were like supposed to get to today, they were like updated for like this year, like the 2021.
Correct, correct.
And there was also the 2021. So I was curious if you're going to be like updating with the new slides, but right before class starts or something.
Yeah,
Because I know it helps me a lot.
yeah, I did, I put the updated slides for 2021, it's called demand. So I was gonna get a third of those today, but I didn't get to them obviously, so
Right,
we'll do that on Thursday.
right. So like, I was just curious in the future, if like you were gonna keep on updating with like the new slides before class starts.
Usually I'll get there before class starts.
Oh, okay.
Yeah,
Yeah, I know it's just easier for me if like, it's
Yeah.
just like one-on-one or like the same. Like as the
so, but
class.
even then, the 2020 slides, the only difference is that the years are different, so some of the
Right.
examples in there. So for example, one of the examples is 20 has the years 2035, it had 2034 and 2059. It's 2040 and 2060 now because of the, 2021, whatever.
Oh, okay.
So just simple things like that are what the real changes are. I don't think I actually with those particular slides. Now these slides are different, the ones we showed today, because all that data is 1 year extended.
Right.
So every one of those things has been updated from the year before.
Oh, okay.
So it really kind of depends on that. But in general, they'll be the same in the same order.
Oh, okay. Yeah, I didn't know if,
So-
like between the 2 years, if like you took out like, I don't know, like 20 slides or added some new slides or something.
I did a lot of that last year. I don't think I'm doing any more this year.
Oh, okay, okay.
Because we rearranged a lot of stuff last year. I think we're gonna keep it pretty much the same this year.
Okay.
So I don't think a lot of that will happen this year.
Okay.
So I think mostly it'll be this, pretty much the same stuff.
Okay. Thank you.
Okay?
Yes.
Yep. All right.
So just for clarification, this week's quiz 1 is that still due tomorrow night?
Yeah, actually, it's at noon tomorrow.
Or I mean, yeah, noon tomorrow,
Yeah.
okay. Another thing, is there a good like life cycle analysis somewhere for electric vehicles? Because people are always talking about how great electric vehicles are, but like, I don't know, I have some doubts because you got to extract those rare earth metals, which also
yeah.
there's a very few.
There
of them
are.
you gotta,
There are some, I would look up the National Renewable Energy Lab. I don't think I show one later in the class. I was trying to think if we had one. But I don't think we look at it that in depth. Oh, we don't look at the full sort of range of life cycle stuff, but we do look at the sort of purchase and the relative sort of annual emissions from the electricity versus the gas. It's kind of different than the whole life cycle, but it's important. So that's the comparison we make later. So I mean, I'm sure there is a full life cycle analysis, but I haven't really seen it though.
Yeah.
But it'd probably be the NREL, National Renewable Energy Lab, probably at least look for that.
All right, thanks. Yeah, because
That'd be
I
my
always
guess.
wonder, you know. but-
Well, yeah, I mean, it's a big question. I don't know, I think I do know, 5 years ago with the amount of coal that was being used to produce electricity, electric cars, it was like Central Ohio, didn't make a lot of sense. But today they probably do, because we moved so quickly towards natural gas and then added a lot of solar and wind into the mix. So I think in a place like Ohio, and suddenly these things are actually making a lot more sense. Associated with the rare earths and stuff like that. So.
They'll
yeah.
probably figure out how to make them without the rare metals.
Well, I
at
just-
some point.
I personally have trouble. I personally have trouble imagining if that's worse than the historical effects of coal mining. and natural gas mining, right? Because those are pretty dirty industries. And they're not a long time. If you look at southeastern Ohio, we have this legacy of acid mine drainage as a result of coal mining, which is ongoing, right? We're still fixing those problems today. So, I mean, I just, and so my guess is probably, we'll find a way to probably substantially just friendly in general, even when all these life cycle things are happening. That's my guess. I don't know.
And, I guess there's like always a thing that's like, keep using your old car until it like runs out and then like buy a new one at some point. Like the used cars will start becoming electric cars, like we won't have to just buy new cars over and over.
I think that's still the right strategy, though.
Mhm.
I think, using your car as long as you can until you have to buy a new one. I think that's typically the strategy for people minimizing capital expenditures and, maximizing profitability.
I'm still using my Toyota Camry. My grandfather, it's older than me.
There you go.
Yeah. All right. Thanks, man.
Yeah,
I'll see you on
ya.
Tuesday, Thursday.
I was just wondering, so for the honor section, is that gonna be in this room or is that gonna be in that other room?
It's 2:21, yeah.
Okay.
Is there anyone in there?
And they just
They're like-
clearly here right now.
It should be open. I didn't get it confirmed that it was reserved, it should be open.
Yeah, we saw like possibly things.
Okay. Well, and it's just like every other week. Did you see the?
Yeah, and it's at 3:55, right?
Yeah.
Okay.
Yeah.
There was in your
I mean, we
reminder.
could do it right afterward if you wanted to.
Yeah, in your email, there was, your reminder email, there was like a typo, it said 4:55, so I just wanted to make
Oh,
sure that I was like, that it was right
No,
now.
no, sorry about that. Dang. Yeah.
No.